ATM stands for Asynchronous Transfer Mode. ATM is a high-speed, broadband transmission data communication technology, based on packet switching, which is used by telcos, long-distance carriers, and campus-wide backbone networks, to carry integrated data, voice, and video information. ATM can be used as the underlying technology for fiber distributed data interface, synchronous optical network, and other high-speed networks. Plus, ATM can run on any media, including coax, twisted pair, or fiber optic. ATM is a connection-oriented protocol that can work with either permanent virtual circuits or switched virtual circuits, depending on your wide area network traffic needs. ATM networks use bandwidth at maximum efficiency, while maintaining a guaranteed quality of service for users and applications that require it. The two main benefits of ATM are its high transmission speeds and its flexible bandwidth on-demand capability. How ATM work? The asynchronous in ATM means ATM devices do not send and receive information at fixed speeds or using a timer, but instead negotiate transmission speeds based on hardware and information flow reliability. The transfer mode in ATM refers to the fixed size cell structure used for packaging information. This cell-based transmission is in contrast to typical local area network variable length packet mechanisms, which means that ATM connections are predictable and can be managed so that no single data type or connection can monopolize the transmission path. ATM technology originated in broadband ISDN technology and works primarily at layer 2 of the Open Systems Interconnection Reference Model. ATM connects devices over a WAN, using virtual channels and virtual paths. Virtual channels consist of one or more physical ATM links, connected in a series for transmitting data between remote stations. A virtual channel exists only while data is being transmitted on it, and all cells in a given ATM transmission follow the same VC to ensure reliable data transmission. A virtual path is a collection of VCs having the same source and destination points that can be used to pool traffic being transmitted to a given destination. A connection-oriented technology. ATM is a connection-oriented technology that requires the establishment of a specific network path between 2 points before data can be transported between them. Typically, a subscriber would lease a T1 or T3 line to connect their customer premises equipment to the telecommunication carrier's ATM network, but frame relay or SONET can also be used to connect a site to an ATM network. The kind of CPE needed varies with the access method employed. For example, channel service unit for T1 line, frame relay access device or router for frame relay, and so on. Large corporate networks using an ATM backbone might use a switch-to-switch connection to the carrier's network, instead of CPE. ATM uses fixed-size packets called cells. Each 53-byte ATM cell contains 48 bytes of data payload and 5 bytes of control and routing information in the header. The header provides addressing information for switching the packet to its destination. The payload section carries the actual information, which can be data, voice, or video. The payload is properly called the user information field. The reason for choosing 48 bytes as the payload size is to compromise between the optimal cell sizes for carrying voice information, 32 bytes, and data information, 64 bytes. The fixed size of an ATM cell makes ATM traffic simple and predictable, and makes it possible for ATM to operate at high speeds. Typical ATM speeds vary with transmission media, and can include 25 megabits per second over unshielded twisted pair, category 5 cabling, 155 megabits per second over either UTP or fiber optic cabling, 622 megabits per second and 4.8 gigabits per second over fiber optic cabling only. ATM also includes a mechanism for allocating bandwidth dynamically, that is, bandwidth is allocated only in required amounts, and the required direction. As a result, when an ATM link is idle, it utilizes no bandwidth, which can result in considerable cost savings depending on the needs of your network. ATM optimizes performance through different classes of service, which can be allocated through QoS settings. This is different from frame relay, which is a classless service. The 4 classes of ATM services that subscribers can specify depending on their needs are: constant bit rate. This service level is suitable for applications that are sensitive to cell delay and cell loss, must have continual availability, and do not require much bandwidth. For example, voice traffic. Variable bit rate real time. This level is suitable for applications that are sensitive to cell delay and cell loss, and require a large amount of bandwidth. For example, video conferencing. Variable bit rate, non-real time. This level is suitable for applications that require a large amount of bandwidth, but can tolerate some cell delay and cell loss. For example, video playback. Unspecified bit rate or available bit rate. This level is suitable for network services that do not have special bandwidth or cell latency loss needs. For example, file transfer or email. ATM provides the following advantages: high speed, fast switched integrated data, voice, and video communication that is not bound by the physical or architectural design constraints of traditional LAN networking technologies. A standards-based solution, formalized by the International Telecommunication Union, that allows ATM to easily replace existing telephony network infrastructures. ATM provides a global telephony standard, and over 70% of U.S. telcos have migrated their internal networks to ATM. Interoperability with standard LAN WAN technologies. ATM networks can be interconnected with Ethernet and token ring LANs, using LAN emulation services to provide TCP/IP over ATM. Quality of service technologies that enable a single network connection to reliably carry voice, data, and video simultaneously, and manage bandwidth on a per connection basis, depending on the priority of the service required. If you want to learn more about networking concepts and definitions, don't forget to press the subscribe button. To be notified when our channel releases another video, click also on the bell icon. And don't forget to visit our website, networkencyclopedia.com.